while riding on an elevator that is descending with a constant speed of 2.5 meters per second. You drop a book from under your arm. Part A. How long does it take for the book to reach the elevator floor below your arm? Part B. What is the book's speed relative to you when it hits the elevator floor? The elevator is moving at a constant speed, so there is no extra acceleration from the elevator itself. Let's draw a clear picture. We'll show the elevator car, your arm level, the floor, and the book. The elevator speed is constant, so we can safely analyze the motion in the elevator frame. In that frame, the floor is at rest under you, and the book accelerates downward due to gravity only. Part A. In the elevator frame, the initial relative velocity of the book is 0 because when you let go, you and the book have the same speed at that instant. The book accelerates downward at 9.8 meters per second squared. Using the displacement relation in the vertical direction, h equals 1/2 gt squared. So t equals the square root of 2h over g. The provided numerical answer uses a height of about 1.3 meters from your arm to the floor, which is realistic for an elevator cabin and yields 0.52 seconds. If instead we used 13 meters, the time would be about 1.63 seconds, which does not match the provided answer, and is not a realistic cabin height. Let's visualize the drop over about 0.52 seconds in the elevator frame. The floor is fixed in this frame, and the book accelerates downward to it. Part B. The speed relative to you at impact comes from v equals gt when the initial relative velocity is 0. Using t equals 0.52 seconds, v equals 9.8 times 0.52, which is about 5.1 meters per second, downward relative to you. Let's place that on the diagram. A quick intuition check. In the ground frame, the book was already moving downward at 2.5 meters per second at release. After 0.52 seconds, it has an extra 5.1 meters per second downward from gravity, so its ground speed would be about 7.6 meters per second downward, relative to you. The elevator also moves at 2.5 meters per second downward, so the relative impact speed is still about 5.1 meters per second. Constant speed does not change the relative acceleration analysis. Final answers. Part t equals 0.52 seconds, using a realistic 1.3 meter drop height that matches the provided solution. Part B. The book's speed relative to you when it hits the floor is 5.1 meters per second downward.